Hello, everyone. I'm glad to be here to share a recent research on beamforming scanning antennas. The topic is a leaky wave antenna with capability of fixed frequency beamforming scanning. These are the contents. Then we start from the background. Leaky wave antenna, as a kind of traveling wave antenna, has attracted significant attention due to their high directivity, easy integration and low profile characteristic. However, inherent frequency scanning characteristics and lack of flexible beam control property limit the development of leaky wave antennas in fixed frequency beam scanning. On the other hand, for beam scanning antennas, the recent research hotspots mainly focus on high gain, wide angle scanning, higher scan resolution, and so on. However, recent works are rarely pay attention to stability of the accepted electrical level and different scanning strategies in complex electromagnetic environment. To this end, in this work, we managed to propose an antenna integrated with two beam scanning capabilities simultaneously, which can provide users with more choices of scanning schemes for applications in complicated environments. Then let's introduce the continuous beam scanning and beamforming scanning. For leaky wave antennas, if the dispersion characteristics of the leaky wave structure can be changed, then beam scanning at fixed frequency can be realized. Thus, beam scanning can be easily realized if the period of the slot can be regulated according to the Formula 1 by using one row of slots. However, traditional beam scanning techniques are proposed for far distance wave coverage and are not suitable for wave coverage in confined spaces or short distance regions, such as tunnels or long straight corridors, where the constant field strength is expected when antenna beam scanning. Therefore, a new kind of antenna with the capability of cosecant squared beamforming scanning is proposed in this paper, which has the characteristics of providing large gain at low elevation angle direction and small gain at high elevation angle direction when scanning, so the target can receive almost the same signal level when moving along a straight confined path. The general principle of the hybrid coding method is to use the same or different codes to control two or more rows of slots, so each of them can generate a beam with required angle and strength for a beamforming. When the beam direction, theta, is relatively small, usually less than 20, a single row of slots is enough to generate required field strength. With the increasing of theta, it is difficult to achieve enough field strength required for beamforming by only one row of slots, so another row of slots is required to compensate the field strength. When theta is larger than a certain angle, usually larger than 30, two rows of slots with the same codes are used. Using this field compensation and hybrid coding method, we can not only get uniform radio wave coverage, but also improve the energy usage efficiency and reduce the electromagnetic pollution. Here show some results about proposed antennae, and it is found that beam scanning and beamforming scanning functions can be realized. Moreover, compared to the available beamforming antennas, the proposed antenna has capabilities of a wider beam coverage range, flexible beam switching, and broadside radiation, which is a preferable candidate for future smart wireless communication. Besides, the antenna proposed in this communication has two beam scanning capabilities simultaneously, which can provide users with more choices of scanning schemes for applications in complicated environments. Thanks for your listening.